So in today's video, we are going to learn about the line of symmetry of a quadratic graph. But first, we will do a recap of the essential concepts first, and then we'll go through the line of symmetry so you can better understand what the line of symmetry is about. And then we'll go through two questions. Okay, so let's do a quick recap. This is the standard form of a quadratic equation, where a is a constant, b and c are also constants, and the highest power for x is 2. Now I will draw a graph of a quadratic equation, where this is the y-axis, and that's the x-axis. So when we say find the solutions of x, we mean find the values of x. And the values of x are the same as the x-intercepts. Now let's move on to the line of symmetry. So say for example, our quadratic graph looks like this. The line of symmetry is the y-axis. By the way, the quadratic graph is also known as a parabola. So the line of symmetry will cut our quadratic graph in half. There are many different types of quadratic graphs. They may cross the x-axis by touching it twice, or once, or none at all. But it doesn't matter. The line of symmetry will still cut the graph in half. Also notice that the line of symmetry is a vertical line. So its equation will start with an x equals to wherever it cuts the x-axis. So let's say it cuts the x-axis at 5. Then the equation for this line of symmetry of the quadratic graph is 5. Now let's try a simple example. In this example, we are going to find the equation of the line of symmetry of the following quadratic equation. Y equals to x squared has the following graph, where this is the y-axis and this is the x-axis. We can see that when x is 0, y is 0. So this parabola will look like this. So you can see that the line of symmetry is the y-axis, and so it will have an equation of x equals to 0. For the next question, which is going to be a bit more tougher, shows a quadratic equation of this form. So step number 1, we have to first find the roots or solutions, and for that we'll use the quadratic formula. So the ABCs of the quadratic formula, you can get it more easily by comparing the above equation with the standard form. So you can see over here that A is 1, B is equals to -6, and C is equals to -27. So we're going to sub in the values of A, B, C into the quadratic formula. This gives us 7. This gives us two different values of x, where x1 uses the plus in the plus minus sign. So 6 plus 12 over 2, which is 9. And x2 uses the minus sign and the plus minus sign. 6 minus 12 over 2, which is equals to -3. So 9 and -3 are two different solutions of the above quadratic equation. So let's sketch out the roots first. So 9 is located here, and -3 is located here. the a is equals to 1. So whenever a is equals to a positive number, the parabola will be non-inverted. It will have this shape right here. Okay, but we do not know where the vertex will be located. The vertex is the turning point or the minimum point of the parabola. The vertex has two coordinates. An x coordinate, let's name it xv, and a y coordinate, let's name it y. So now notice that if I draw a vertical line that cuts through xv, like so, this vertical line is in fact the line of symmetry because it cuts the parabola in half. So because it cuts the parabola in half, to find out where it cuts the x-axis in half, we just have to simply add up the roots. So minus 3 plus 9 over 2, because it is in the middle of the two roots. So all we have to do is sum up both the roots and divide that by 2 to find the midpoint, which is 3. So the equation for the line of symmetry, for this quadratic equation right here, y equals x squared minus 6x minus 27 is x equals to 3. So as a bonus question, let's go through one more question, yeah? So y is equals to x squared minus 7x plus 8. So recall that to find the line of symmetry, we have to add up the roots of the quadratic equation divided by 2. Right, so we have to find the roots first. To get the roots, we'll use the quadratic equation. But first, we have to find our a, b, and c's first. So comparing the above equation with the standard form, we can see again that a is equals to 1, b is equals to minus 7, and c is equals to 8. So now we'll substitute our a, b, and c's into our quadratic formula, which is x equals to this. This gives us two roots, where x1 is equals to 5.56 and x2 is equals to 1.44. Let's sketch our quadratic graph now. So remember that the line of symmetry is the x-coordinate of the vertex, and the vertex is the minimum point of the quadratic graph, which is also called a parabola. So what could the x-coordinate of this vertex be? Okay, so we have to sum up x1, x2 and divide by 2. Okay, so 5.56 plus 1.44 over 2 gives us 3.5. So the equation for the line of symmetry of y equals to x squared minus 7x plus 7 is x equals to 3.5. So to determine the equation of the line of symmetry, we have to find both the roots of our quadratic graph, add them up together, and divide by 2. Because the line of symmetry is located in the middle of the parabola, it cuts the parabola in half. And to obtain our roots x1, x2, we have to apply the quadratic formula, which means we have to find our a, b, and c, and that requires knowing where to find them. Often writing out the standard form helps. So I hope that all of these examples here is helpful to you. If you find it so, please subscribe, because I'll be posting very similar examples and questions, a lot more of them in the near future, and you'll be able to gain access to them for exam prep and test preps. Thank you.